Welcome to our demonstration, Query-Driven Video and Processing in Internet of Multimedia Things. Event processing system mine data patterns over incoming sensor streams based on user queries and send notification when an interested pattern is detected. For example, here a user can write a declarative event query language like energy consumption at a specific room location over a structured sensor stream and perform real-time event matching and send the pattern when it is detected. But the world is now transitioning to Internet of Multimedia Things, where visual sensors like CCTV cameras are pervasive. But current event processing systems have certain challenges to process video event patterns, like they lack declarative event query language. Secondly, this video data is having an unstructured data model. Thirdly, how to perform spatiotemporal matching, where video event patterns happens in both spatial and temporal dimensions, and how to handle complex DNN model pipelines. To overcome our challenges, this demonstration presents GNOSIS, which is a query-driven video and processing system. GNOSIS follows a serverless approach where its components act as a microservices. GNOSIS constitutes of 7 major components: query manager to deploy event query language, stream manager to publish the video data stream, content manager to extract video content and convert into a video graph event, matching engine to perform stateless and stateful video event matching, adaptation engine for autonomic workload balancing, forwarder and benchmark platform controller to generate a different outputs and evaluate the system performance. The GNOSIS microservices communicate through a messaging service. GNOSIS constitutes of event processing language, which is built over OpenCipher query language. This allows users to write SQL-like declarative query syntax. If we look into GNOSIS data flow, initially the video stream is processed by Stream Manager, and then different metadata has been extracted from complex DNN model pipelines in the terms of object detections and its attributes, characteristics, which are later encoded into video event knowledge graph. This knowledge graph is later updated, its relationships are updated in matching engine, and when it gets matched with the query, a notification is generated, which is sent to the subscriber. In this demo, we will show different complex queries related with occupational health and safety scenarios. So the query 1 is about counting number of workers wearing hard hat workers. With the DNN model hard hat detection, and a no search is performed to detect a hard hat, and finally a worker count is sent. So if we look into the demo, initially different GNOSIS microservice components are initiated, and then later we are going to connect these microservices with the GNOSIS UI. So now we are connecting the UI with the GNOSIS cluster node. And here we can write in the query editor, and then the media source, from media source, we can select the video data and publish it and submit the query. And here that the worker count is 3 in the video. The query 2 is about detecting hard hat compliance event. So here again, we are using a hard hat DNN model, but right now we are matching with worker having hat and non-worker which are not wearing hard hat over a temporal operator, that is a tumbling window here. And finally, we sent a compliance status, which is a Boolean operation. So if we look here again, we have pasted the query, selected a data file, published the video data stream, and the same way query 2 is subscribed in the system. And if we look here specifically, initially the compliance status is false, but when the person has wear the hard hat, the compliance status has become true. Here the compliance status is true because all the 3 persons are wearing hard hat, but in this video compliance status is false as 1 person is not wearing hard hat. Query 3 is about worker versus visitor classification. So here we will count number of workers and visitors, and there are different output we can go in the terms of graphs as well as tables. In this queries we are using 3 DNN models. One is person detection, hard hat detection, and color detection, where a spatial overlap top operator is used to identify a person wearing yellow hat, and another spatial overlap top operator where a person is wearing white hat. And we can give some threshold values like overlap top of with 60% threshold value. If we look into the query, so when we pasted the query and again stream the data source, different outputs like graph based output can be shown, table based format can be seen here. And in the same way, we can see that here the worker and visitor count is 1, where the detection is happening using the pipeline of 3 models. GNOSIS constitute benchmark platform controller. Here different evaluation metrics can be given, like the system can be configured with different queries like adding a query and deleting a query. And then there is a GNOSIS benchmark dashboard where we can evaluate the system performance like latency, throughput, and per service latency to identify metrics of each microservices. Thank you.